In this video, we're going to create and replicate the Reddit NFT drop with a powerful, seamless user experience for people who aren't as familiar with Web3 concepts like creating a wallet, setting yourself up with funds, or even what NFTs are in general. By the end of the video, you'll have a web application where users can log in with their email and have a Web3 wallet created for them and have NFTs minted to them after they click the Mint NFT button without ever signing transactions or paying for gas fees for the NFTs being minted. Before we jump into the video, I want to let you know that currently 70% of the amazing people like yourself that watch ThirdWeb's YouTube videos are still not subscribed to the channel. So before we begin, I'd love to ask you a favor. If you get any value out of these videos, I'd really appreciate it if you subscribe to the ThirdWeb channel. And a little tip is we're going to be airdropping 10 users who have subscribed to the ThirdWeb channel a very special NFT every week. So what's so special about the Reddit NFTs? We have an excellent thread over on our Twitter, which will be linked in the description if you want to get a quick summary of how Reddit released the NFTs onto their platform, but I'll give you a quick overview of my thoughts on it as well. 4 months ago, Reddit made this post saying introducing collectible avatars, and they're kind of dodging the NFT word to kind of not get people off the hype, in my opinion, but nonetheless, they are NFTs and they're calling them collectible avatars. Now, Reddit has this character up here called a snoo or something like that, and essentially you can get these customizable snoos and you mint a snoo NFT such as this one, which is my one here, and you kind of get these randomly generated NFTs. For example, I have meme team snoo number 499,917, so it's quite a lot of them. And the way that you qualified for these NFTs or be able to mint these NFTs was based on your kind of how many virtual points that you had on the Reddit platform, which is called Karma. And I believe you needed around 2,500 Karma on Reddit to be eligible to mint one of the NFTs from the drop. But you might be wondering in your head, what's so special about this drop? It sounds like a typical NFT drop that's randomized traits and you claim an NFT. And I think the answer to that question is what kind of problem Reddit solved was they have a large number of Web 2 users who aren't familiar with Web 3 concepts like what a wallet is, what an NFT is, why you would mint an NFT, why you would care about this at all. And they've kind of built this really seamless, powerful user experience, combining different methods to onboard, hundreds of thousands of Web 2 users into the NFT world. And that's being reflected in the price of some of these Reddit NFTs selling for, hundreds of thousands of dollars on OpenSea, on secondary markets, and things like that. There's a few key elements that we think make up such a seamless user experience when minting NFTs. The first one is that you don't actually connect your wallet at all throughout this process. You have a wallet created for you called a vault that is kind of this abstract concept away from Web3 wallets. One of the most intimidating things for people being onboarded into Web3 is creating a wallet, getting funds into that wallet, paying for gas when you're minting NFTs and transactions. And there's a large number of kind of stepping stones into the NFT world that Reddit has completely skipped over by allowing you to just connect your Reddit account and it creates a wallet for you called a vault is the name of what they're doing. You just have this kind of social login and you don't ever deal with Web3 wallets and you don't ever deal with gas fees, which is the second point. So Reddit is actually paying the gas fees behind the scenes for minting the NFT into your wallet. So you don't create a wallet, you don't pay any gas fees, you just kind of have this NFT minted for you into your wallet and into your possession, and you can choose to do with that what you want. You can sell it on secondary markets if you choose to do so. You can keep it on your Reddit profile and you can equip it, which is what I've done with my meme team NFT here. I've just set it up as my profile's image. So pretty cool. And that's what we're going to be replicating today. We have this kind of seamless user experience. We're going to be allowing social logins with users' emails using a tool called Magic.Link. So you'll type in your email, you'll be generated a wallet, Web3 wallet, and we'll be creating and replicating that gasless experience where we'll be covering the gas fees for the user. The user doesn't have to sign anything, and the NFT will be minted into that wallet that they've just had created for them using their email. So with that background knowledge, let's jump right into the building. Okay, so I'm going to jump into the terminal here as the first step. And what we're going to do is we're going to create a new application, a React application with the ThirdWeb React and TypeScript SDKs installed. And to do that, we can use the CLI. So we're going to say npx thirdweb, and to get the latest version of the ThirdWeb CLI, we're going to add the @latest tag, and we're going to run create here. So we're going to create a new project with ThirdWeb. First question it's going to ask us is to install the latest version of the CLI. And then it's going to ask us if we want to create an application or a contracts project. For us, we're going to be creating an application. So we're going to select the application option when this is done installing here. Excellent. Here we go. So the first question is, do you want to create an app or a contract project? For us, it's going to be app. We'll give our project a name. Let's call it Reddit NFTs. And for this video, I'm going to be using Next.js and TypeScript because we are going to be using a server-side environment using Next.js API routes. Sweet. So that's going to take 1 minute approximately to install all of the dependencies and pull down the code. But we can open it up in Visual Studio in the meantime and take a look. So let's open a folder up here. And what have we got? YouTube into the Reddit NFTs folder here. And while the dependencies are installing, we'll see the node modules folder start to build out here, but we have 2 pages in this project. The first one here is this _app.tsx page where we have the ThirdWeb provider wrapping every page within our application. So the component always gets wrapped in the ThirdWeb provider, and we can define which chain ID we want in the application here. So for us, the Reddit NFTs are on the Polygon network. We can use either Polygon mainnet here by saying chainid.polygon, or we can use the Polygon testnet by saying chainid.mumbai here. And we'll get some autocomplete as the dependencies start to install here, but I'm just going to show you in the background while that's happening. So we're going to set this up on the Polygon network. I'm going to be using the test network just so we don't use any real funds. And there'll be a guide in the description if you want to get yourself set up with some test funds on the Polygon testnet as well. The other page that we have here is the home page, and it's quite simple. All we have is just some boilerplate code. Welcome to ThirdWeb. Here's how you can get started, some resources, and we have this simple connect wallet button that allows users to connect their wallet with a variety of popular Web3 wallets. But of course, we're going to be allowing users to sign in with their emails. So let's take a look at our server here. Sweet, looks like it's done. We'll just reopen this so we get the autocomplete happening. And if we go to our app TSX page now, give it a second to load, we should see now we are connected to the chainid.mumbai. So you can see all of the options available, all of the EVM compatible chains. And we have either Polygon for Polygon mainnet, or we have Mumbai here. Excellent. Okay, so now we have our application set up. What we're going to do is actually create and deploy an NFT collection. So to do that, we can jump into the ThirdWeb dashboard here. So we'll go to thirdweb.com/dashboard, and we'll connect our wallet. I'm going to use MetaMask for this video. Just set up my password here. And what we're going to do is from the available contracts that we have here, let's go ahead and select the, looks like we selected the wrong thing. We're going to select the deploy new contract button here. And from the available contracts within here, we're going to select the NFT drop contract. So we're going to have ERC 721 NFTs that are available to be minted by other users. So we're going to lazy mint or upload all of the metadata for our NFTs, and we're going to have other users be able to mint them. So what we're going to do is we're going to jump into the drop ERC 721 and we'll click the deploy now button. Here's where you'll be able to set up the metadata of your smart contract itself. So you can upload an image, you can upload a name, you can upload a symbol or a ticker for each of the NFTs within the collection. So I'm going to upload the yellow star image here, and we'll call it Reddit NFTs. And for the symbol, we can do Reddit and a description, hello world. So you can populate this however you like, and you can set up primary sales, so the wallet address that receives the funds for minting the NFTs. In our case, it's going to be free, so I'm not too concerned with this, as well as royalty fees. So you can set up how how much royalties you want to take on secondary sales and which wallet address will receive those royalties. You can set up advanced things like platform fees, but for us, we're just going to keep it simple and we'll set it all to 0. So when you're ready and you're happy with your metadata and your primary sales and royalties, you can select the Polygon network if you want to deploy to Polygon mainnet, or for us, we're going to use the testnet, which is the Mumbai Matic testnet down here. And we'll go ahead and swap our wallets over to the Polygon testnet Mumbai. And we'll go ahead and hopefully I have some funds here. Yep, looks good. So we'll click deploy now. So we're going to deploy our smart contract to the Polygon testnet. And the first thing it's going to do is ask us to approve the transaction to deploy our smart contract. So deploy proxy by implementation. And if you want to learn more about what this transaction particularly means, about how we have proxy smart contracts to allow you to have very cheap smart contract deployments, there'll be a resource in the description to learn more about our proxy implementations. You can go ahead and confirm this transaction, and in the background, your NFT Drop smart contract is going to be deployed to the Polygon test network. Sweet, and the contract is successfully deployed in the background, and here we'll be taken to our NFT Drop smart contract dashboard. Now from here, there's 2 key things that we need to set up. The first one is, as you can see here, we need to set up claim conditions, and the other thing we need to do is actually upload the NFT metadata that we want to be minting to users. So let's do that first. We're going to go to the NFTs tab here, and I'm going to batch upload some dummy metadata that I have. You can see the format that is required for these metadata files in these example CSV, example JSON files, but I'll show you the ones that I'm going to be using. So we'll go to repos here and we'll go to the demo assets that we have. And within here, let's open this up in VS Code. And I'll show you the structure of the metadata that we're going to be uploading. So here we have the CSV file. So you can see we have name, description, shape, color, and these are all properties of the NFT. And within the JSON file, we have a very similar structure. We have the name, the description, the image, which just points to a file within this images folder, such as bluecircle.png, obviously points to bluecircle.png. And if I go back to the file here, we have green circle points to green circle, etc., etc. And this is just the example metadata that we're going to be using in this video. So let's go ahead and drag the images folder as well as the JSON metadata file into the drag and drop area here. And just confirm your metadata is how you expect, because when you upload this, is going to be completely immutable in IPFS and stored forever in decentralized storage. So let's click next button here, and here you have the option to reveal upon mint, which just means your users, when they mint the NFTs, will be able to see them straight away, or you can add the option to reveal the real underlying metadata of the NFTs at a later date using a delayed reveal. We're going to be just keeping it simple and saying reveal the metadata as soon as the NFT gets minted here. When you're happy, you can click the upload NFTs button here, and your NFTs should start being uploaded to IPFS and pinned to IPFS in the background. And when they are completely uploaded to IPFS, you'll be prompted to accept this lazy mint transaction where your NFT metadata will all be uploaded to the blockchain. But at this point, your NFTs aren't actually minted. They're just kind of prepared for other users to actually mint them. In our case, we're going to be minting them to the users' wallets as they attempt to claim the NFTs from our application on that server side. So that transaction has gone through, and now we'll be taken back to the NFTs tab, and you can see we now have a total supply of 30 NFTs ready to be claimed. 0 out of 30 have been claimed so far, and we have an unclaimed supply of 30. So the next thing we need to do is set up the conditions under which users can mint the NFTs from our drop. So we'll go over to the claim conditions tab here. We'll click the add initial claim phase button down here. And here you can see we can configure all of these properties, such as a release date, how many NFTs we want to release, how much we want to charge for minting each of these NFTs. And in this video, we're just going to keep it super simple. We're going to say we'll mint all 30 of our NFTs. You can mint 1 NFT per transaction, and you have to wait unlimited time between claiming those NFTs, and we'll charge 0 Polygon to mint each of the NFTs, so it's going to be free. Once we're happy with those claim phases, we'll click the Save Claim Phases button down here. We'll approve this multi-call transaction, and our NFTs will be ready to be minted inside of our application. Excellent. So our claim phases are set up. Let's jump back into our application here, and we'll close that metadata off. We're ready to connect to our smart contracts. So on the homepage, let's just get rid of this boilerplate code. And the first thing we're going to do is if you go to the code tab on your smart contract, you'll see you can use the command that we ran at the beginning of the video to create the application. And the first step is to actually connect to your smart contract. So we're going to use the use contract hook from the React SDK, which is already installed from this command that we ran. And we're going to pass in first the smart contract address, which is the address up here. You can copy and paste. And the second is the type of contract that we're going to be connecting to. In our case, we've deployed the pre-built NFT Drop smart contract. So we just pass NFT Drop here. So let's go ahead and import the use contract hook, and we'll start to connect to our smart contract. So I'll go ahead and copy and paste the smart contract address in here, and we'll import the use contract hook, and we'll grab the contract out of that object that gets returned. So we'll say contract is equal to use contract. The first thing we want to pass is the smart contract address. So we'll just paste that in here and just format that a little bit. So, all right. And the second thing we want to do is the NFT drop as the second parameter. And of course, we'll import the use contract hook, and we're good to go. So that's imported from the @thewebdev/React package automatically for us. And now we can access all of the functionality of the contract object here. So we're going to say contract dot, and we can see all of the functionality available, such as ERC721 dot mint.claim, get all owners, get claim transactions, all of these really powerful features already available for us just by connecting to our contract in one line of code here. So now we've connected to our smart contract, let's set up the wallet connection. And what we're going to do is use a tool called Magic.Link, which allows users to connect to your Web3 applications using the typical kind of workflows of using their email or using social media such as Google to log in to your application and have a wallet generated for them. You can see a little preview of what we're going to be using in this video on the side here, where the user types in their email and has a wallet created for them. Every time they retype in that email, they'll have an email sent to them that looks like this one, where you have a login to the application that we've set up. They click this button, get redirected back to the application, and they're signed in to the Web3 wallet and can access all of the funds and all of the NFTs that they have for them. So what we're going to do is we're going to first set up the Magic.Link connector. We'll add a button and a text field that allows users to connect to our application using their email, such as this one here. So here I've already connected and it reconnected automatically, and it detects my address of my Magic.Link wallet. So if I click disconnect wallet here, I'll give you a quick preview. We can then type in my email, so jared@theweb.com, click the login button. What it does is sends an email to my wallet, or if I've already confirmed that email, it just signs me back in automatically, since that's kind of stored in local storage in cookies and things like that. So that's a really good experience. There's no wallet required, no approvals of a MetaMask or setting up funds or anything like that. Just a seamless experience that Web2 users are already used to. So for Magic.Link, you'll want to go ahead and create an account on their website, magic.link. And I've already created one in the background, so just go ahead and log in here. And here we'll get a taste of what the experience is for users when they type in their email. They have an email sent to them. So I'm going to go ahead and click that off screen so I don't show you all my emails. Click the link, and here it'll take you back after you click the link from your email back to the dashboard, and you'll be signed in to your account automatically. And in our Web3 application, users will be signed into their Web3 wallet just using their email. So once you're on the dashboard here, go under Magic Auth and we'll create a new application, and let's call it my Reddit NFTs, and make sure you have Magic Auth selected here and go ahead and click Create App. Now here you'll be given a publishable API key and a secret key. The one we're interested in is the publishable API key here. So let's go ahead and copy this into our application. And what we're going to do now inside of our app is set up the Magic.Link connector in the TheWeb SDK. Awesome. So back in our application, what we can do is utilize this API key to initialize the Magic.Link connector. So if we go back to VS Code, the first thing we need to do is import the Magic.Link connector from the @thewebdev/React/EVM connectors magic. So we have magic connector here. And what we're going to do is we're going to instantiate a new magic connector class using our public key that we've just copied from the dashboard. So firstly, we'll say const Magic.Link connector is equal to new magic connector, and you can see the config options available for us to provide to this class here. We have chains and options. So for options, we want to pass in our API key in that object here. So we're going to say options is a object. Within that object, we have our API key, and you'll use your API key from the dashboard here. Beneath that, we have an RPC URLs object, and we need to configure the chain that we've set up as our active chain ID. We need to provide the RPC URL, which you can get from the Magic website as I have here, or you can provide your own public RPC or private RPC URL, however you choose to connect to the blockchain. And that's it for initializing the Magic.Link connector. And beneath this, we're going to set up the Magic.Link connector defined in the third web provider. So within here, we're just going to add wallet connectors, which is an array of connector types or wallet connector objects that the dApp supports. For us, we're only going to support Magic.Link. So within this array, we just pass in the Magic.Link connector, which is this instantiation here, into that array. And now we're ready to use the Magic.Link connector hook inside of our homepage. So on our index.tsx or our homepage here, the first thing we're going to do is import the use address hook from the React SDK here. And we're going to use this hook to detect if there's a connected wallet address. So this accesses the currently connected wallet address if there is one, or it returns undefined if there isn't a connected wallet address. And we're going to use this for some conditional logic to display the connect button if the user hasn't connected yet, or the connected wallet address if the user has connected. So beneath that, we're going to use state hook from React, and we're going to use this to store the user's email as they type it into an input box. Finally, we're going to use the use magic hook, and this comes from a little bit of a different import than the usual React SDK. This comes from /react/evm/connectors and magic. And what we're going to do is we're going to use the use address hook, and if there's not a connected wallet address, we'll have a button that allows users to use this use magic hook to type their email in, submit it to the Magic.Link connector that we configured in the app.tsx file here. And what that'll do is send them an email that they'll be able to click and come back to our application in that signed in state. So inside of our components, we're going to use the use magic hook, store the result of that in a function called connect with magic. So this is a function that uses the instantiation that we have here to allow users to type in their email and send that to the function that'll allow them to click that email that gets sent to them and sign in with their email. Beneath that, we're going to store a stateful variable called email, where users will type in their email in an input box that will get stored in the email field here, and we'll use that as part of the connect with magic hook to send the email along with that function. Beneath that, finally, we're going to use the use address hook, which, as we mentioned, is going to grab the currently connected wallet address if there is one. Beneath that, we're going to use this ternary operator logic on the address field here. So if there is an address, then we're going to simply just display a message saying you're connected and here's your wallet address that we grab from that hook. If there's not an address, or if address is undefined, meaning they haven't connected their wallet yet or logged in with that magic link, then we're going to show an input form that allows users to call this connect with magic function. So here we have the form where we just have some simple title text saying login with email, and a div beneath it where we're going to have first an input and secondly a button that calls this connect with magic logic function here. So first we have the input. Every time a user types a letter or deletes a letter in this input field, we're going to call set email, which is that stateful variable up here. So every time this field changes, we're storing the updated value in that stateful variable, so we can send the most up-to-date email value along with this connect with magic function here. Beneath the input, we have a button that when clicked says call the connect with magic function and pass the email as the sort of configuration to that function. So we're just passing an email. This is the same as saying email is equal to the email stateful variable that we have stored. And that's what we're doing, passing along that to our connect with magic function. So if we test this out on our localhost here, we can run npm run dev or yarn dev if you have yarn installed. We're going to visit localhost 3000. Looks like I already have it running actually. So I'll visit localhost 3000 here. And what you should see, if you zoom in a little bit, you'll see this form where we haven't connected our wallet yet. So we get this kind of false state where we don't have an address. So we see this form here. So we have the login with email and the div containing the input and the button. What we'll be able to do, this is just an extension that I have, so you won't see that. What we're going to do is type in our email. So I'm going to use my ThirWeb email here, jared@thirweb.com, and click the login button. What this will do is let us know, check your email. We've sent you a Magic.Link that will allow you to sign in to this application. So check my emails here. It says login to Reddit NFTs, which is the name of the application that we configured in our dashboard here. So I believe this is called Reddit NFTs. Yep, my Reddit NFTs. And if you go back to your tab, it says don't close this tab. Just keep checking your email until the user clicks on this login to my Reddit NFTs, at which point there'll be a message that says you're logged into my Reddit NFTs. If you go back to this tab, then it will automatically detect that you've signed in with your email. It'll come back to this state and say, okay, now there is a connected wallet address. Here's your connected address, as you can see here. So now we've kind of achieved our first goal of logging the user in with kind of a Web 2 familiar way where they don't have to interact with any kind of Chrome extension, wallet, Web 3 specific knowledge in order to interact with our decentralized application. The next thing we want to do is we want to allow users to mint the NFTs from our drop, but we don't want them to sign any transactions or deal with having to load their wallet with funds or anything like that. So the kind of architecture that we're going to do here is we're going to allow users to click another button in this connected wallet state that allows them to call a logic on our server. And on that server, we'll initialize the ThirWeb SDK from our admin wallet private key using the same wallet that we deployed the NFT collection to. That wallet has permission to mint or claim to specific wallets and will claim to the wallet address that gets sent from the client. So what we're going to do is mint the NFTs to the wallet address that's connected on the client here. And that way, the user doesn't have to pay any gas. Our private key that we initialize the SDK with, or that wallet, will be the one paying the gas on behalf of the user and claiming or minting those NFTs to the wallet address. So to do that, we're going to create a function here. We're going to call it async function mint NFT. And within this function, we're going to call an API route that we're going to create. So we're going to say, call the mint NFT API route. Wait till the transaction on that API route is complete and result is sent back to us. Show that information on the UI. So basically, we're going to ask the server to mint the NFT to the connected wallet, wait till that comes back, and then when we kind of come back to the client with that information of the minted NFT, we can say to the user, hey, you've been successful in having that NFT minted to you. And the user hasn't had any kind of interaction with their wallet whatsoever up until this point. So beneath the kind of connected wallet state here, where we have you're connected, what we're going to say is add a button that says mint your NFT. And here we're going to say on click, let's call this function that we just said. So mint NFT, I believe is what we called it. Yep, mint NFT. So every time this button gets clicked, we're going to run the logic within this function here, which currently is nothing. So it's going to do nothing whenever we click it. But in theory, when we have this API route and this logic built out in this function, we're going to have the NFT minted to our wallet address that we send in the kind of body of this request. And then we're going to say, here's the result of that server running that code. And hopefully, if that's successful, then the user will have the NFT minted into their wallet. So to create the API route, we can go into pages directory in our project here. And we're going to create a folder called API, and we're going to create a file within that called mint-nft.ts. And this is just going to be a boilerplate Next.js API route with TypeScript. I'm hoping GitHub Copilot helps me just populate the boilerplate stuff here. Export default function handler. and this is going to accept a request and a response, and then we'll just return some dummy data. So this is the basic kind of structure of a Next.js API route. You accept a request, and with this res object, you can return data to the client. In this case, we're returning a JSON message with a name of John Doe. So it's just dummy data coming back from that API. And we can do whatever we want with that when we store the result of this fetch call to this API route on the client here. So what we're going to do is we're going to say const result is equal to await fetch the path of the API, which in our case is API mint NFT.ts. And within the body here, within the body of the request, we're going to pass the connected wallet address, which in our case is the wallet that gets generated for the user when they sign up with Magic.Link. So we're going to pass the stringified address as part of the body of this API request to the Mint NFT API route here. So that's the suggestion that I wanted. As part of the body, we'll pass the address in an object, and we'll be able to access that address inside of that API route. And we don't need any headers, I don't think. So let's just close this off, and then let's console.log the result. And with this basic boilerplate API route, all we're doing is just returning an object saying John Doe. So if we go to our localhost 3000, what we should see is we'll get this kind of flicker while the address loads, or the Magic.Link address loads. And then on the UI, you'll be able to see this mint your NFT button here that allows you to call that API route. So when we click it, it's going to go to the server here, which I'm not sure what I did wrong here. Okay, so we need the header of a post. So whenever you pass the body, I believe you need a post. So we're going to add headers, content type application, and I believe we need post request here. So let's add method cannot have a body. Fetch. Yeah, method post. Okay, so that's what I was looking for. It just needs to be a post request rather than a get request when you're passing this body here. So with that said, I don't even think we need the content type here, but let's just leave that in for good measure. And we'll give this a quick refresh. Again, we'll get this kind of flicker state where we have the login state. When that connected address gets read from local storage, then we'll have this connected state. When we click the Mint Your NFT button, that goes to our server. The server-side logic runs and returns the result to the client. And you can see in the client here, if we take a look, all that's run is a status 200. And if we grab the body, which I should have done, I should have console logged the body of the request, we would have this information from the API back where we have kind of dummy object come back from the server that says, here's the data. And what we're going to do is we're going to replace this dummy data with a function that mints the NFT. We'll grab the resulting transaction of minting that NFT. We'll send it back to the client to show to the user to say, here's the NFT that you just minted. So before we do that, I have an important disclaimer of the kind of logic that I'm going to run on this server. I'm going to be storing my private key in an environment variables file inside of this env.local file here. This is not a practice that we recommend at all at ThirdWeb. We have a page talking about the risks of storing your private key in plain text or even in environment variables. And we strongly recommend that you have a read through this page. Anybody who accesses your private key has full control over your wallet. So you never ever want to leak or put your private key at risk when you're developing your applications or in general. So I would strongly recommend you have a read through this page and do not follow this environment variables practice that I am in this video. If you want to keep your funds safe, I would definitely recommend reading through this page and setting it up in this more secure manner. I'm just using a dummy throwaway account for this video. And that's why I'm comfortable leaking my private key in an environment variable and putting myself at risk here. But if you do care about your wallet and you do care about your funds, would strongly recommend that you use an account that you're comfortable with and use the sort of methods that we recommend in this page here of using a secret manager to keep your private key safe. So with that disclaimer out of the way, let's jump into the Mint NFT API route here. So let's get rid of this boilerplate code. Let's close off the pages over here. So what do we want to do inside of this API route? We want to grab the connected wallet address that we sent as part of the body to this Mint NFT API route. So let's do step one, grab the address out of the request body. From the request body, two, let's instantiate the ThirdWeb SDK using our private key. And then 3, mint an NFT to the address from the drop, from the NFT drop that is. And then finally, let's return the transaction info to the client. So basically we're getting the address, minting an NFT to that address. When that transaction goes through, we'll let the client know, here's the information for you to use and display that to the user. So what we're going to do first is we're going to destructure the address out of the request body. So we're going to grab address from request.body. And this is the address that we're passing here on line 21, where we pass the address as part of the body of this post or this fetch request here. So that's what we're doing on line 6 in the server side here. Then we can go to the portal documentation, we can go to backend applications, and we'll instantiate the SDK from our private key here. So we're going to copy and paste this snippet here, where we say ThirWeb SDK from private key, provide our private key here. And again, it says learn more about securely storing your private key on this following page here. And then we're going to set the network that we want to interact with on the blockchain. So we're going to configure this to Mumbai. So let's copy and paste this into our application here. And of course, we need to import the ThirWeb SDK. So we're going to add that from @ThirWebDev/SDK, which is our TypeScript SDK. So let's, instead of saying your private key here, I'm going to use environment variables. Again, I would not recommend that you do this if you care about the funds in your wallet, but I'm going to say process.env.privatekey, and let's cast that as a string just to make TypeScript happy here. Excellent. All right. So let's just make these comments a bit cleaner. Then what we're going to do is we're going to connect to our smart contract. So let's maybe say to B. Yeah. Let's connect to our smart contract using its address. So we're going to grab the contract address from the homepage here. So let's copy and paste this. Let's store that as the address here. Const contract address is equal to this value. And then we're going to use the SDK to connect to our smart contract. So we're going to say const contract is equal to await SDK.get contract. And again, we're just going to pass the address here. We're going to say contract address. And the second optional parameter here is the type of the contract. So for us, it's going to be NFT drop. And looks like this is not an async function yet. So we're going to just convert this to async, export default async function. And then we're able to use this await keyword here. So now we can start to interact with that contract on the server side. It's kind of the same process that we followed on this line here, where we just connected to our contract. This is using the React SDK, so it just looks a little bit different in terms of using the TypeScript SDK and the React SDK. But essentially, we're just doing the exact same thing. We're instantiating the SDK and then connecting to the smart contract. And now we can call all of the logic available on this contract object here. So the one we're interested in is, let's say const transaction is equal to contract dot claim to. Here it is. So claim to, and the two parameters that you need to provide here are the wallet address that you want the NFT to be claimed to. And when I say claim, I'm really just saying mint to. Claim is just a word that we use to claim NFTs from the drop. So if you remember on the dashboard, we lazy minted or batch uploaded the metadata. And the process of claiming is actually minting those lazy minted NFTs. So essentially what we're doing is minting to a specific wallet address. And as you can see here, the first argument here is the destination address, which is the address you want that NFT to be minted to. So for us, that's going to be address. And we're going to cast that as a string. And then the second thing is the quantity. So how many NFTs do we want to be claimed to that address? For us, I'm just going to keep it simple. I'm going to say let's mint 1 NFT to that address here. And we'll save that. And now we'll await this value. So we'll say await. And in the transaction, we now have a transaction result with ID of type NFT. So what can we do with that transaction? We'll see. Transaction dot. It looks like it's an array, so we'll try to say transaction 0.data.id.receipt. If we want the ID, that would be the ID of the transaction. If we want data, I'm actually discovering this as well, along as I look at it here. We can see data.metadata. We can grab all of the information about the NFT that the user just minted. But what we're going to do here is in step 4, we're just going to return that transaction to the client. So we can kind of say, okay, here's what you got back from that transaction. So what we'll do is we'll say console.log transaction. And we'll say res status 200 transaction, and we'll pass the result of the transaction to the user. And what we're going to do is let's inspect this on the server. But if this transaction fails, we want to kind of handle that. So what we're going to do is we're going to say try, paste all of this in a try catch block. And if this fails, we'll just return an error message to the user, and we'll pass the error back in a 500 response. So we can kind of handle that on the client to say, okay, is the response okay? Is it a 200 response? Then we can access the transaction, everything succeeded. But if it didn't, then we can see what went wrong in this error message here. Cool, so now we have the logic on our server. Let's just handle the logic of having that NFT minted and show something meaningful on the UI when that transaction does come back. So what we're going to do is we're going to add a nice little loading state up here. So we're going to say const loading and set loading is equal to use state, and we're going to use a Boolean stateful variable, and we'll default that to false. So when we call this mint NFT function, we're going to set that loading state to true, and we're going to run this in a try catch block here. So let's say try, make an API request to that, we'll catch an error. We'll say console.error, error, and maybe alert the user that something went wrong. Please try again. And finally, we'll stop loading. So we'll say set loading is false whenever any of these are finished running. So we'll give that a quick save and format. And now within this try block, we're ready to kind of handle the result if it does come back. So we've got this kind of error handling state, and we can grab that kind of information of the error that came back from this line here if we choose to do so. I'm just going to keep it simple and say something went wrong. But what we can do if everything goes to plan is we can show the user a message saying, here's the NFT that you just minted. So what we're going to do is we're going to grab the JSON returned out of the API. And this way, so let's grab the API here. So we'll say const response is equal to await result.json. And essentially, we can grab the object that gets returned. So we have transaction here. And I believe this response will contain that transaction. So we can say, let's show the user the transaction ID when the transaction comes back. So we'll say alert response dot transaction ID, I believe it's called. Let's just double check here. Transaction, I believe it's an array. So we'll say response 0 dot ID. It's not transaction ID, so we'll change that to ID. I'm just going to double check this is the kind of thing that we're expecting here. So we're going to say console log response, take a look at what that looks like on the client here. So let's go run this localhost 3000 again. Let's run yarn dev, visit localhost 3000, give it a quick second to load here. And what we should see when the address gets detected is this mint NFT button. And let's maybe show some kind of loading state while that's happening. So when you click the button, let's say beneath that, let's say if it's loading, we'll have some loading text and we'll disable the button while it's loading. So we'll say disabled equals loading. And if the loading state is true, so say loading question mark. If that's true, we'll have some text that says loading. Otherwise, we'll have some text that says mint NFT here. And we'll close that button off. So now we have a kind of nice little loading state. Let's give this a quick refresh again. And when that loads, we will see the Mint NFT button. When we click it, we should see this loading text beneath it. That button becomes disabled. Code is now being run on the server side in the Mint NFT function. So we're instantiating the SDK, we're minting the NFT to the connected wallet address, and then we'll return that transaction to the client here. And I'm just going to take a look at what the console is saying. Let's just clear this out of the way for a second here. The first place we should see it is the server here. So you can see here is where we're console logging the transaction here. Looks like I've scrolled out of the way, but you can see the transaction, the array of transactions here. The first one contains the ID, the receipt, what happened, and then we can access the metadata if we choose to do so. And that will be returned in this line 30 here, where we return that to the client. And then back on the home page, we can see we're console logging the result. Let's see what we have here. we're alerting object.object, but what I'm most interested in is this result here. So we have ID, we have receipt, we have all of this information that we can grab from the transaction returned to us. And we could show the user any of this information if we choose to do so. You could just say a simple message saying, hey, your NFT got minted. But what we're going to try and do is show the metadata of the NFT that came back from that transaction. And if we take a quick look before we try and do that at the dashboard here, you can see I've been cheating a little bit in the background. So I've minted 2 NFTs so far, and I changed my claim conditions a little bit around to be allowed to do that. But I've minted 2 NFTs. Both came from this kind of application. The second one here is the one that we just minted from the application, clicking this Mint NFT button here. And you can see the ID OX01, which just translates to 1 in our case, is the token ID of the NFT that we just minted. So if we wanted to return the data of the NFT, what we could do here is we could say return transaction 0, which is the first NFT that got minted, I believe. And we can grab data. We'll call that and we'll say data.metadata, and we'll return that metadata object. So within that metadata object, we can access things like the ID, the image, the name, the properties, all of the information about the NFT that got minted itself. And you can see my formatter automatically added this await. I guess the data function is a promise, as you can see here. So we need to await that. And now maybe this will be cleaner if we said const metadata is equal to await this. And then what we'll do is we'll just return the metadata here. So that looks like we're forgotten an await again here. Cool, there we go. All right, so we're awaiting transaction data, and then we grab the metadata out of that, and then we return that in the status on line 33 here. So with that information in the kind of response here, we can see now that we'll have a metadata object, and we can console.log that metadata. So let's rename this to minted NFT metadata, and we'll console log that. Then what we can do is maybe we'll show it on the UI. So maybe let's have another stateful variable called const minted NFT, set minted NFT equal use state. And we'll add the type here. I'm not sure what this type actually is. What is it? Transaction.metadata.data, transaction0.data here. Sorry, I'm just going to figure out what the type is. And this returns a promise of NFT. So let's import the NFT type here. And we'll say undefined. We'll import this NFT type from the ThirWeb SDK here on line 6. Now we'll say this is either an NFT or undefined if we haven't minted an NFT yet. Then what we'll do is when this comes back, we're going to say set minted NFT to the minted NFT. And let's cast this as NFT here. So now we have a typed variable called minted NFT. When the transaction comes through, that NFT metadata will be set in minted NFT here, and we'll be able to access it on the UI. So beneath this kind of loading operator here, we can say, let's show the minted NFT when it comes back. So what we're going to do is we're going to say minted NFT. If there is a minted NFT, then we'll render this here. Let's just close that off. And what we'll do is we'll say div, and we'll say h3 your minted NFT. And we will use the ThirWeb NFT media, ThirWeb NFT media to provide the metadata of the NFT. So pass that in, and this is going to be nft.metadata. And I guess it's not happy with us for some reason. Identifier expected. This needs to be metadata, sorry, not NFT. Cool, now it's happy with us. And this is going to render the media of the NFT, whether it's an audio file, a video file, or an image. It's going to resolve that from IPFS. It's going to present that to us on the UI. So it's a really handy UI component for us here. Let's give this a quick style of just width 300. Sure, that sounds good. And then beneath that, we can say, let's say the metadata.name. That sounds good to me. So now we're displaying the NFT the user minted when it comes back from that transaction. So what we should see if we go to localhost 3000, give it a quick refresh, hoping that we've nailed this. We can fix it up if we haven't. So when this wallet connects, then we'll show the Mint NFT button here. When we click it, it's going to mint again on the server. So let's go ahead and click this button here. Get this loading state. When that transaction goes through on the server, then we'll have this loading state false. The button will go back to normal, but we'll show, instead of loading here, we'll show this minted NFT metadata that we have available for us in the state now that we've set that as that transaction goes through. So when this transaction goes through on the server, then that'll come back to the client. We have the metadata available to us, and we can use that to display it on the client here. So it looks like we made a little mistake. Let's see what we did wrong here. So we're not actually getting the results. So we have result.json, minted NFT metadata. What I should be console logging here is minted NFT metadata. So let's console log this and we'll see what's wrong here. So it looks like we typed the response a little bit wrong here. We've got NFT instead of metadata. So what we're actually returning is the metadata rather than the full NFT response. So we can just simply resolve that by changing this from NFT to NFT metadata here. And we'll get rid of this NFT import. And now down here, what we can do is we can say metadata is just the minted NFT, since that is the metadata object now. And down here, instead of .metadata, we just have .name, since that is the actual metadata itself. Cool. So now if we give this a quick refresh and we sign back in with our account here, so let's say jared@thirdweb.com. Let's quickly log in. And since we've already got that kind of stored logged in state inside of our local storage here, we don't have to accept that email again. We go straight to this your connected state and we can see this Mint NFT button here. So let's go ahead and click Mint NFT, get this loading state, and hopefully this time when the response comes back, we'll be able to see that on the UI. And with this is a full kind of Web 2 approach, I guess, to creating a Web 3 application where you sign in with your email. You don't have to sign any of these transactions. And this is kind of how you can create such a powerful user experience, such as the Reddit NFT collection, where you don't have to interact with any of the kind of painful or new nuances of Web3, like a wallet and signing transactions and paying gas fees. And as you can see, this time we were successful. We just fixed up that type. We have your minted NFT. Here is the metadata of the NFT that we just minted. This is the image that's being rendered by that NFT media renderer component with this image. And if we go to the dashboard here, you can see the yellow circle is the latest NFT that we minted. So this is the one that we've just claimed or minted from that server side API route. That's been minted to my wallet address. So you can see the connected wallet address that I have is, sorry, that won't be MetaMask. I'm not sure why I'm checking MetaMask. You can see the connected wallet address for the Magic.Link wallet that got created for me is OXD123. And the owner of this token here is owner OXD123. So this is going straight to my Magic.Link wallet address here. And we're rendering all of that NFT metadata for us on the UI. That's it for today's build. If you have any questions about today's video, feel free to view the full source code for the project in the description, or jump into our Discord server where you can speak with myself as well as the rest of the Third Web team directly for us to be able to answer any of the questions you might have about this video, about Third Web, or about Web3 in general. We'll be there to help you out. With that said, hope you enjoyed this one, and we'll see you in the next one.